Okay, hello everyone, and thanks for watching. Y'all, today we're just going to review counting and probability. That's kind of what we've been looking at here last week. Guys, our essential question, and today you don't have to write it down, but why is it important to learn how to count? I know it seems like a strange thing to ask, but it's important to learn how to count things. Sometimes things are kind of hard to count. All right, the reason we're doing it during probability is that probability, again, is a ratio. It's a fraction. We have to count all the number of events that we're measuring, and then we have to count all the possible outcomes. All right, we have to count those things. So we learn different methods on how to count things. Guys, the first one we looked at was the fundamental counting principle. This is when we have independent events. All right, we take them and just multiply them together. Okay, if there's m ways to do something and n ways to do something else, for both of them to happen, or how many different ways that both can happen, just multiply them together. Okay, remember we had problems like about a pizza or about making a sandwich. Well, there's different kinds of bread and different kinds of meat and different kinds of cheese that you can choose from. You multiply those numbers together to find out the total possibilities. And you can think of it as like a tree diagram. All right, you want to know all the total possible ways that something can happen. You multiply the independent events together, the different number of ways that the independent events can happen individually. But sometimes we have dependent events. You know, when we choose cards from a deck and we don't put them back in. All right, so it becomes one less each time. And as an example, the arrangement. Arranging books on a shelf. Okay, if there's 5 books on a shelf, we can arrange them 120 different ways. Because I can put 5 in the first slot and 4 in the second slot, 3 in the third slot, 2 in the second to the last slot, and then 1 in the last slot. Okay, we've talked about that before. And that's called a factorial. Okay, we use factorial because it's a notation. It's like a shortcut, all right, to write successive whole numbers decreasing that we're multiplying together. The product of consecutive whole numbers decreasing. All right, then we learned about permutations. Guys, and if we're permutating all the books, all 5 of them, where we're going to 5 permutate 5, that's the same as 5 factorial. All right, because the bottom becomes 0 factorial, and we know that equals 1. So if we're arranging all the books, it's basically 5 factorial. However, sometimes we only want to arrange part of the set. We might only have space enough for 2 books, but we have 5 books we're choosing from. But we want to arrange just 2 books. All right? So we use a permutation, because we're just looking at the first 2 slots. All right? Because we only have 2 spaces to put our books. Again, another example would be 8 runners running in a race. All right, how many different ways can they finish first, second, and third? Again, not all 8 runners. We just want to fill 3 slots and arrange them. So again, it's 8 times 7 times 6. And again, that's a permutation. Because 8 minus 3 is 5 factorial, so 5, 4, 3, 2, 1 is eliminated. And we just get the 8 times the 7 times the 6, just the first 3 positions. Again, that's called a permutation. It's an arrangement of some or all the objects in a specific order. Okay? This is the formula. We looked at it. Again, we're permutating, we're picking from n items, but we're arranging r items at a time. Again, in a permutation, order does matter. Guys, but sometimes order doesn't matter. Like again, the example we talked about is running a qualifying race with 6 runners, where just the top 3 finishers move on to the next round. Order doesn't matter, just group the top 3. All right, well, it's not 120 ways like it was before. It's only 20 ways. All right. If you notice the group here, 1, 2, 3, there's no other group in here that's 1, 2, and 3. None of these say 1, 2, and 3. Okay, so that's one group. But that group 1, 2, 3, I can rearrange it 6 different ways. All right, that's why the combination is less than the permutation. Because the permutation takes each group and rearranges it. The combination just takes the groups. All right, again, a combination is a set of objects with no specific order. A combination is a grouping, where a permutation is an arrangement. All right, and the only difference is this r factorial on the bottom, because we divide out the number of arrangements within each group to get a combination. And a good way to think of it is like this. Guys, this is the formula for combination. But you can think of a combination as the permutation, again, divided by r factorial. Again, r factorial is the number of arrangements within each group. We are eliminating the number of arrangements within each group because we're just counting the groups. All right, guys, also then we looked at probability. And there are 2 types of probability problems that I want you to know for the test. And this is one of them. What is the probability of getting exactly 4 heads if you flip a fair coin 7 times? The problem will be something like that. Again, the probability that an event occurs, it's a ratio. It's a fraction. Right? The number of outcomes on top and the number of outcomes that were of the event occurring goes on top, and the total number of possible outcomes goes on the bottom. All right, the number of ways that this event can occur is 7 combine 4. 7 group 4. How many groups of 4 can I get from 7? All right, that's how many times I can get 4 heads if I flip a coin 7 times. Order does not matter. It's just any one of those 7 times, I want 4 of them to be heads. All right, but the bottom here, again, is the total number of possibilities. Each time we flip a coin, I can get heads or tails. So 2 raised to the 7th. 2 times 2 times 2 times 2 times 2 times 2. 7 times, okay? All right, the next problem I want you to learn is the one about the classroom with the boys and girls, where they're picking a president, vice president, and treasurer. So order does matter. This is a permutation problem, and it's a ratio of 2 permutations. All right? The top permutation just looks at the boys, because in this problem, we're saying that all 3 positions are filled by boys. Now be aware, if they want the girls, all 3 positions filled by girls, then you have to use the girls. Right now we're talking about the boys. So out of 15 boys, how many ways can I arrange 3 of them? But the total number, you use all the students. In this case, there's 28 total students, 13 girls and 15 boys. So how many ways can I arrange 3 out of all 28 students? That's the bottom number, okay? Also, you're going to have to pick between the type of problem. Is it a permutation problem? Is it a combination problem? Or is it a fundamental counting principle problem? Okay, look for the keywords. If it says something about a list or putting in order or a lineup or arrangement, something like that, it's a permutation. If they're just saying choose or form groups or something like that, that's a combination. And remember, the fundamental counting principle is independent events. They just multiply together. We're not forming groups. I'm not choosing one from another. All right? They're independent events. All right? Guys, that's it. Thanks for listening.